In this video, we're going to show you how to run a bucket test to check the calibration on a flow meter. Okay, Mel, show them what we got.
A pump, a meter, and a valve.
There we go. Pump, meter, valve.
Got some pipes.
How big is this pipe? Half an inch. 90-degree elbow.
Okay.
You remember what this was?
No.
Union.
Union.
What's the union do? Joins two pieces of pipe.
Joins them both.
Joins them together. We've got this demo cabinet that's got a switch and a 120 volt AC to 24 volt DC power supply and a WaterFeature8 mounted on a panel integration kit. Okay, well, the point of the video isn't really to do a plumbing lesson. Okay. All right, Mal, what do we got? Step forward.
So we have the pump, the meter, and the valve. And this is where the water will go through. So it'll attach from here and here, and the water will run all the way through here and come out the other end.
Yep. Cool. What's this, Mel?
It's a bucket.
How big is the bucket?
A gallon.
How many buckets should we use for a 3-gallon bucket test?
3 buckets.
3 buckets. Can't get anything by it. Okay, so I pulled the panel integration kit out. Just made it a little easier to wire all this up. That's what I was going for. Get a good picture of that. Looks pretty good. Right here. Right here. There you go. Yep. So power, that's our input power, 24 volts coming to the board. Red is our VCC from the meter. That's powered off of the 5-volt terminal here. This white one is our ground, and it connects with the probe ground here. And then this black one, or this white cable right here, is the pulse off the meter. And the reason why we do that, you gotta hold that steady, babe. The reason why we do that is because all of the channels on this generation of WaterFeature8 are isolated ground. And in order for the meter to work, it needs to be on isolated ground. So that's our little hack for now. Generation 3 is gonna work. It's gonna have all those isolators taken off. So that's how you pop that guy in there. I think we're ready to go. Should we run it for a test?
Yeah, we should also run that thing.
Yeah, we'll do that. Okay. Okay. All right, here we go. We're set up. Ran a dry run just to see how it worked, and it did work. Here's our receiving bucket. A little bit of water in there. Here's our source bucket. Pump is down in there. Meter's right here. Meter's hooked up to the WaterFeature8 in this panel. There's our valve, our union, piping, and we'll pipe this over here into the white bucket in a second. You'll see in here I've marked the white bucket. There's our first gallon right there, and gallon number 4. Marked it on the inside because it's a little easier to read. Gallon 1, gallon 4. So there's 3 gallons between those 2 marks. So what we're going to do, Mal, when we turn on the pump, get that in there. When we turn on the pump, we're going to set a stopwatch, and we're going to start that stopwatch when it hits that white line. And then we're going to stop it when it hits this line. And then we'll know how many gallons from there to there. And then we'll...
White line?
This black line. Yeah, I meant black.
Oh, okay.
Black line down here to this black line here. And the time that it takes to go between the two and the flow rate that it is telling us will give us an indication whether or not the meter is accurate.
Okay.
And if the meter is not accurate, we'll be able to adjust the K-value to make it accurate for these 3 gallons. There we go. We've got a flow of 0. I made up a K-value of 0.002. Actually, it was 0.00175, but it only shows so many digits. All right, let's go ahead and turn the power on. All right, and then we'll get ready to start timing here. Right about now. Meter's running. It says we're getting 5.46, 5.5, 5.45, 5.5-ish, okay? So we're gonna watch this. When it gets to that line, we'll hit the timer. Still 5.4, 5.4. Might call this 5.5. All right, ready? Time. Here we go. No problem. And it goes down to, should go to 0 and that thing stops spinning. Okay, we just stop moving. No. Okay, so the math works like this. So we're going to go into remote state again here. REM, 45 seconds should be enough. Okay, we go into remote state, so it's coming down. So I'm going to say S3, comma, K, comma, clear. Okay, so S3, comma, K, comma, question mark should return 0, and it does. So now we say S3, comma, K, comma, our number is 0.00152. 0.00152, comma, 1. Enter. It gives us an error because I've got the OK signal turned off, but there's actually no error. So if we go say S3, comma, K, comma, 1, it should give us a value. There's the number. The software rounds it up. That's coming out of the EZO. Unfortunately, the EZOs make it difficult to figure out exactly what the numbers are in there if you've got, you know, a high frequency like that. But I know what the number was. I put it in there, so that's okay. All right, so that's good. That's our new K value is 0.00152. So now we're going to rerun this test. Reset with water. Go back to 0. We should be getting about, our target was what, 4.76 gallons per minute. So let's turn this pump back on. It's not too bad. I'm pretty happy with that. Pulsing like crazy. There it is. So that's really about it. That's all there is to setting the K values in your meter. Now that would be for a single K value. If you have multiple K values and you have a meter that has multiple K values, then you are going to have to reset all of them and then start all over. And my advice to you is figure out what the flow rate range is typically going to be and use a valve. I don't really care what kind of valve, but use a valve and throttle the flow back to different points and get you multiple K values. And that theoretically increases your accuracy across a broader range of flows. But for this, one instance, in this pumping scenario I've got here, every time this pump turns on, that's about what it's going to flow. So, so I don't really have a need to have multiple K values. But if you had a situation where maybe it was variable frequency drive regulated, or you had a metering pump of some sort that could change speed dramatically, then you know, that would be a totally different scenario. So I hope that this helped you think about the flow meters and how the K-values work, and the math really isn't that hard. We'll clean it up in the formal video that you guys see, and then we'll have some better instructions. There is a little piece in the frequently asked questions that you can review, and some stuff that you can look at, and then you know, if you have any questions, of course, you can just give us a holler, and we'll try and get sorted out for you. Hope you enjoyed the video. Thanks, and you know, have a great day.